everyone. Today we are going to talk about IoT and XR technologies. The paper that we are presenting today is entitled Extended Reality in IoT Scenarios, Concepts, Applications, and Future Trends. We start with an introduction to the paper, the motivation behind the topic, and the concepts that have been discussed in this paper. And then we continue with the background of IoT building blocks and different XR technologies. Then we review some of the industrial and academic projects that utilize IoT technology to enhance their virtual environments. Um, and then we will talk about the proposed data communication model to translate IoT data into XR applications in this paper and some of the future applications of this area, and also at the end we conclude the paper and some of its research gaps. IoT refers to a network of physical items or things that have sensors, software, and other technologies built into them in order to connect and exchange data with other systems and devices through the internet. They are enabling smart cities and the fourth industrial revolutions. Um, According to Statista, the number of IoT devices is forecast to almost triple from 9.7 billion in 2020 to more than 29 billion IoT devices in 2030. Uh, According to IoT market is expected to grow 385.9 billion USD in 2021 to 566.4 billion USD in 2027 at a compound annual growth rate of 6.7%. On the other hand, we have XR technologies, and they are building new experiences in entertainment and education. XR is an umbrella term encapsulating AR, VR, MR, and everything in between. And according to Statista, the global augmented reality, virtual reality, and mixed reality market reached 28 billion USD in 2021, rising to over 250 billion USD by 2028. And considering the strong growth in IoT and XR technologies, the intersection between these technologies is something that hasn't been fully explored though. So pioneering projects are leading the way to show the potential of bringing IoT and XR technologies together, and such projects make use of online experimentation concepts, which is defined as the use of remote or online access to virtual 2D or 3D simulated experiments or augmented and virtual reality applications for interactions with sensorial devices, and the OE tools allow increased user immersion in real systems or in their virtual replicas. Um, in this paper, the authors uh, discuss the concepts, devices, and challenges of IoT and XR technologies, and they discuss the current applications of XR technologies in IoT scenarios and propose a data communication model to translate IoT data into XR objects, events, or scenarios. Um, so if you want to talk about the building blocks of IoT, it is demonstrated in this figure, and the external environment. We have external environments, and we have sensors. So sensors sense the external environment, and actuators which affect the external environment, like a speaker. And when these two are connected and remotely accessible, tasks can be automated, such as playing a sound on the speaker when a certain temperature is reached. And Data analytics allow visualization of events occurred and understanding how and why they occurred. Um, so if here we have the definitions of VR, AR, and MR, and we can see the differences between these three types here in this picture. VR makes different cognitive interactions possible in a digital artificial world, therefore immersing users into imaginary worlds. And it has gained visibility with the entertainment and gaming industries because it allows to easily transform the abstract into reality. Oculus Rift and HTC Vive present themselves as the most powerful VR headsets. Um, and the main challenge of VR is motion sickness. Um, However, using the right combination of methods and devices, it's possible to reduce this problem to acceptable levels, even in experiences where locomotion is heavily present. In contrast with VR, we have AR, which allows interactions with virtual objects that are placed in the real world environment, and devices like smartphones and tablets can be used to experience AR as they usually have the necessary sensors such as camera, gyroscope, digital compass, GPS, and others. Google Maps and Street View AR apps are examples of AR, and just by pointing the smartphone's camera to a street, the app overlays objects in real time on top of the camera picture, um, such as arrows to help the navigation or rating of nearby restaurants on that street. Uh, to define the experiences that blur the lines between VR and AR devices, the term mixed reality was born, which breaks the barrier between virtual and real environments, and it combines AR and VR technologies in order to produce new environments and visualizations where physical and digital objects can coexist. Here we review some of the industrial and projects that used these technologies together. One of the most advanced ones uses one of the most advanced users came from an elevator manufacturer who helped their technicians with elevator maintenance and repair by using HoloLens. And as seen in these pictures, the company began by linking the sensors and systems of its elevators to the cloud. And the cloud service logs and saves elevator data, including the motor's temperature, the shaft's alignment, the cab's speed, and the operation of the doors. Rapid component identification and failure diagnosis are made possible by real-time data displayed through cloud access. And in the demonstration video, the technician can be seen using augmented reality to inspect the 3D model of the elevator, highlighting information about the damaged components. And it also shows the technician evaluating the faulty component within the elevator and learning more about its state while getting instructions through the Skype on how to fix it. Um, Networking company, hardware company Cisco also has VR video demos to showcase three different IoT scenarios. The first one is a factory automated repair, and it shows a factory with robot arms that have on them IoT devices to monitor the state and conditions of the arms. And anytime the arm presents a malfunction or a problem, the IoT devices can collect and automatically send the fault information to a hub. And if it's a specific piece of malfunction in IoT devices can make an order for a replacement and issue a repair to that machine. And VR in this instance, as it's depicted in the picture, can show how the devices are set on the environment and how the flow of data works. It also provides pop-ups with information every time the user looks at something new. In the second video, which shows a smart city environment and how IoT can improve the day-to-day life of a person by giving real-time information about roads traffic and roads repairs. It also shows statistics in real time that can be collected by companies. Again, VR is able to show the big picture by providing top perspective views of the city and simulate the traffic, highlighting the IoT devices and how they are connected and their technical details. The third video shows how IoT can monitor a residential area and in case of a catastrophe or power cut, inform the emergency services and utilities suppliers on how to deal with the problem. IoT can help automate rerouting of power to the affected zones, collect relevant data, and quickly send it to the respective entities for a better understanding of the problem at hand. It can also provide status information to the citizens to keep calm and informed about the situation. And again, in this case, VR allows visualization of all of this. If the rescue or repair team is called to the site and the crew needs training for that particular problem, the video demonstrates that VR would be very useful in providing real-time remote communication and collaboration with an expert. And that way the crew can quickly assess the problem and receive real-time instructions in order to solve it. One of the academic projects in this area comes from X-Reality Research Lab, in which they created a virtual environment of things architecture, providing network topology visualization and digital twin. And this example shows how MR technology allows for new ways to visualize physical objects. And in this paper, they used HoloLens in their work. Another academic project is VR binoculars, and they started by pointing out that IoT devices are always related to physical space, and which means GIS fundamentals can be leveraged. As a result, there are two characteristics for IoT, including sensor data and physical location. So they developed two prototypes, weather visualizer and Bluetooth sensor. In weather visualizer, XR devices make sense of the room to find specific objects on walls, in this case light strip installations that are linked to the weather stations located on the roof of this office. And then XR devices lay out the information like temperature on top of the light strips. The second prototype is a Bluetooth sensor that connects with the XR device, allowing to grab the simulation, the information, and display it on top of the sensor. So in this paper, they proposed a general data communication model, and so which in this model which converts IoT data into XR objects, events, or scenarios. And as you can see, the model is represented in this picture, and there are four elements in this model, including IoT devices, cloud, IoT to XR interface, and XR devices. And the novel component of their model is IoT to XR interface. And this is a software module that would receive IoT data and analyze it by filtering and aggregating important values. And then the output of this module would consist of treated data, XR objects, events, or scenarios that could be easily added to any XR application during development and or runtime. To clarify their model, their communication interface, They provided two use cases. One of them is a smart city use case, and in this use case, consider that there are several sensors, including temperature, humidity, and noise sensors, deployed through the city and collecting real-time values. And these values are being uploaded in real time to a cloud server. So when a user on a XR device wants to visualize this data, like average temperature, humidity, and noise in the last 3 hours on a 3D map of the city, using this model, what happens is that XR application sends a request to the interface asking for sensor information. On the interface side, after receiving the request, it identifies the context as a smart city. It fetches the requested data from the cloud server and filters it. During filtering, the interface organizes data from each sensor into profiles, which will contain all information about that sensor, and then interface also calculates the average temperature, humidity, and noise collected from each sensor in the last 3 hours and assigns a color to each value, like for example low green, medium yellow, or high red, and assigns a 3D object type to each sensor and adds all that information to each respective profile. Finally, it aggregates all the profiles into package and sends it to the XR application. The XR application receives this packet, and for each profile, it generates the respective 3D object, colors it with the assigned color, puts it on the 3D map using the location details, and prints the average values next to it. In another use case, they consider a situation where malware is propagating among IoT devices and security analyst wants to visualize this propagation. So the only difference here is that the use case is different. So um, the data which need to be collected from the network is different, and security analyst. So here, XR app sends a request for indicator of components on IoT devices, and interface identifies the context and fetches data from the cloud. Again, assigns 3D object types to each IoT device and colors for level of detection and arrows for active connections, and put this information on beside each device. In a nutshell, IoT and XR together allow data-rich complex scenarios to be transformed into accessible applications that blend real and virtual worlds in order to offer enhanced and more natural interactions between human and data. Uh, since education is increasingly important in society, therefore the creation of more applications combining XR and IoT together in this field is highly promising, and this is mainly because these technologies offer a way to show or simulate working systems without the need for the real device. And if gamification is applied, the experience can monitor the student's action and act if a student struggles or does something wrong, providing incentives like tips and or more detailed information for the student to achieve success. Another future application could be cybersecurity, giving rising importance of securing computer networks and especially IoT devices. They foresee the use of XR and IoT in cybersecurity to help security defense teams to defend against computer malware attacks. This could be achieved by using XR experiences to provide enhanced visualization of the computer networks. Um, and Also for marketing and product sales, VR plus IoT can provide a useful channel to communicate with investors, not only to show infrastructure but also to allow easier visualization and understanding of ideas. And uh, so in the conclusion, as a conclusion, and this presentation, we talked about concepts of IoT and multiple forms of XR, existing projects which are using IoT data in their XR applications, and also a generic data communication model uh, is proposed in this was proposed in this paper. However, they didn't provide any implementation or analysis of their proposed model and how they address security and latency issues in their proposed model. So, in my opinion, conducting more research to address the security and latency issues in transmitting IoT data to XR applications is needed. And these are the references that I used in this presentation. Thank you for your attention. Any question?